Hi, this is the video for Chapter 8, Lesson 3. This is part 2 of Lesson 3. So in this lesson, we're going to take a look at a different kind of special right triangle. And before we talk about that, let's take a look at where it comes from. So this special right triangle is actually half of a equilateral triangle. So look at this triangle here. We know that equilateral triangles have all three of the same sides, and the angles are all congruent. So if we wanted to break down the actual angles of just half of the triangle, if this is 60, this is 90 degrees, what would half of 60 be? Well, this angle right here would be 30 degrees. This angle right here would be 30 degrees, right? So we can see that this type of triangle is part of a equilateral triangle. So this is called an equilateral or equiangular, you could say that too, triangle. And the angles of the two triangles are 30 degrees, 60 degrees, and 90 degrees. And so we call this a 30, 60, 90 triangle. Now, let's talk about the relationships of the sides. So we know that all sides of an equilateral triangle are congruent. So if I knew that this were 10, what would this section be? Well, we can see that this is half of the side, so this would be 5, right? So I'm actually going to give it a variable, and let's say that this part is x. If we were to relate that to the other side here, that would be 2x, right? And then if we wanted to work out the Pythagorean theorem to find the third side, we could. And so long story short, I mean, I guess we could work out the Pythagorean theorem, but long story short, basically this height of the equilateral triangle, or what we call the long leg, is x times square root of 3. So the relationships of the three sides is that we've got the short side, short leg, the long leg, and the hypotenuse. So those are the sides that make up this. Okay. The short leg, if it were x, the hypotenuse would be 2x. And the long leg would be x times square root of 3. So I'm going to name this A. The 30, 60, 90 triangle theorem basically says that A equals x times square root of 3, or the radical of 3. So it's x, 2x, and x rad 3. So you can think of it as 1, 2, 3. And you've got to be careful with this one that you don't mix up the height and the hypotenuse. You easily want to say that the height is 2x because from when we looked at the 45, 45, 90s, you might, kind of bring some of that idea into this, but we've got to be very clear here not to mix those up. So looking at these two examples, I've got my hypotenuse. So that means my short leg is going to be half of the hypotenuse, right? So that would be 3. And then this height would be 3 times square root of 3. Okay. In this case, I have the short leg is 2. So the hypotenuse would be double what that is, which is 4. And this would be the short leg times square root of 3. Okay. So you can see the pattern. You're starting to see the pattern there. Let's do a few practices on your study guide. So on your study guide, on the back side, it talks about 30, 60, 90s, and it actually displays how the Pythagorean theorem here, when you work that out, gives you x times square root of 3 as the heights there. So, okay, so taking a look at this. The short leg is 1/2, which means the hypotenuse is double what that is. So x should equal 1. And y would be the short leg times square root of 3. And I like to think of the square root of 3 especially belonging to this type of triangle because this has a 30 degrees. And so that 30 degrees, the 3 and 3, 30 degrees, square root of 3, that's how I kind of remember the pattern of these triangles here. Okay, number 2, the short leg is 8, so the hypotenuse would be double what that is. So y would be 16, right? And x would be 8 times square root of 3. All right. Number 3, the hypotenuse is given to you. So the hypotenuse is 11. The short leg should be half of that. So that would be what, 5.5? And then the height would be 5.5 times square root of 3. Okay, so hopefully you're starting to get the hang of the pattern. Now we're going to take a look at if we were given the height instead, the long leg, okay? If we were given the long leg, what would we do? So looking at number 4, we know that the relationship between the short leg and the long leg is that it's the short leg times square root of 3. So we know that if the long leg is a number times square root of 3, well, we could just divide it, right? Divide by square root of 3. And so x would be 9. And then y is double what x is. So y would be 18. Taking a look at number 6, again, the hypotenuse is given to you, so y is 10, and x would be 10 times square root of 3. All right, let's go back to our notes a little bit. Let's just briefly go over what happens if we are given the hypotenuse, or actually the long leg, but it's a whole number. So similar to what we were doing with the 45, 45, 90, where we had to work backwards, we're going to do the same thing here, right? The relationship between the long leg and the short leg is that it's the short leg times square root of 3 equals the long leg. So I'm going to say x times square root of 3 equals 9. Well, in this case, I'm going to follow the same idea, same method of working this out to get x by itself. Well, if I divide by square root of 3, then I get rid of that here. And I'm left with 9 divided by square root of 3. Remember we talked about we don't want any radicals as our denominator, so we've got to get rid of it. We're going to use the same method by multiplying the same thing on the top and bottom to get rid of this radical on the denominator. So what we see here is square root of 3 over square root of 3 is really just another way of saying 1. So when we multiply these, square root of 3 times square root of 3 is just 3 on the denominator. And then what's on the numerator is 9 times square root of 3. So when we look at this, can we simplify 9 and 3? I think so. So this would be 1, and this would be 3. So our short leg is 3 times radical 3. And then our long leg would be double what this is. So our long leg, our hypotenuse would just be, let's say that this is y and this is x, okay? So our long leg would be 6 times radical 3, double what that is, right? Double that. Okay, so do you notice something? Previously with the 45, 45, 90, we saw the relationship was that the side was, if we were given the hypotenuse, the side would be half of it times square root of 2, whereas in this case, it's dividing it by 3 and then multiplying it by square root of 3. So the idea would be that the short leg would be 12 divided by 3, which would be 4, times square root of 3. And then once you find the short leg, you can easily find the long leg. So let's just double check. I'm going to use the same method to make sure I do get 4 times square root of 3. So again, if I'm given 12 is my long leg. I know that equals the short leg times square root of 3. So I'm going to divide both sides by square root of 3. And then I have, my pen is not writing great. Square root of 3 times square root of 3 on both sides equals x. And when I multiply it out, I have 12 times square root of 3 over 3. 12 divided by 3 is 4. And so I'm left with 4 times square root of 3 equals x. And so my long leg, or my hypotenuse, would be double what the short leg is, which would be 8 times square root of 3. Okay, does that make sense? Hopefully it makes sense. So let's go back and take a look at our study guide. This time they've given us the long leg, it's 12. Oh, we just did that, didn't we? So our short leg would be that divided by 3. So 4 times square root of 3. And then our long leg is double that, 8 times square root of 3. Okay, let's look at these last two problems here, 7 and 8. An equilateral triangle has an altitude length of 36 feet. So we also can call this the altitude, right? So they're saying this is 36. An equilateral triangle. So this is our equilateral triangle. I'm going to draw that. Determine the length of a side of the triangle. So we're saying, what would be one of our sides? So in other words, we're given the hypotenuse, or the hypotenuse, and no, not the hypotenuse. We're given the altitude, we're given the height, and so we're going to use that to solve. And so we know the relationship of the altitude and the short side is that divided by 3 times square root of 3. So 36 divided by 3 is 12 times square root of 3. And then to find the long side, right, this whole length, because what we found here is the short length, that's 12 times square root of 3 as this length here. And so to find the entire side, we double that to find this other side as well. Add them together, so that times 2, which would be 24 times square root of 3. All right, number 8. Find the length of a side of an equilateral triangle that has an altitude length of 45 centimeters. Okay, so here's our equilateral triangle. Here is the altitude, 45. And again, it's asking for the same thing. Find the side of an equilateral triangle. So the relationship between the long leg and the short leg is that times the short leg times square root of 3, but to work backwards, we could do this divided by 3, which would be 15 times square root of 3. And then to find the entire length, it would be that doubled, so 30 times square root of 3. Okay, so let's take a look at some practice problems here. I'd like you guys to let this sink in a little bit and do 9 through 16. When you are done, you can play the video again and check your answers. So pause it, work those out, and then check. Okay, so you can take a look and check your answers. One thing I do want to talk to you about is that if you have the short side being a number times square root of 3, the long side is double that, right? So it's like y would be 10 times square root of 3. And then x is really just this long, sorry, the hypotenuse is 10 times square root of 3. The long side, or the altitude, is this times square root of 3, right? So think through. 5 times square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is just 3. So then it would be 5 times 3, which ends up being 15, right? Because altitude equals x times square root of 3, or the short side times square root of 3. So you see the square root of 3 show up a few times here. And then if you're working backwards where you're given the altitude, then the short side would be that divided by square root of 3. So y would just be 21, and then x is double what y is, so that would be 42. And so number 5 and 15 and 16, draw the picture out when in doubt. draw out an equilateral triangle, and then it says find the length of a side of the triangle. So you're looking for that hypotenuse there. Okay, hopefully that kind of clarifies things. If you have questions, just let me know.